Hey, this is the lesson, a reteach of the G.CO.9, kind of recap of it, makes it a little bit shorter compared to what we did last time in the last video. This is proofs about theorems and lines. I mean, angles and lines. So like the theorems about angles and lines. So one of the things that you need to know is what this symbol means right here. If I were to put like double arrows right there and double arrows right there, that means that those two lines are what? If we have those double, this is kind of recap. See if you remember this. If two lines have two symbols, so like this symbol, and that symbol with it. You know what that means?
Parallel?
Yeah, that means that they're parallel. And in fact, we call this, those are the parallel lines. And then we call this line right here, we call this line the transversal. I think it's so funny because it's like parallel lines with another line that goes through it is technically what it is, but they call it parallel lines cut by a transversal. So with that, we get all sorts of different angle relationships. And the easiest one to start with, well, an important one to start with is corresponding angles. So corresponding angles mean they're angles that are in the same position relative to the parallel lines and the transversal. So what I mean by that is notice angle 1 here, angle 1 and angle 5. They're both above the parallel line and they're both above the transversal. You could kind of say like to the left of the transversal and maybe to the right of the parallel lines. So in relationship to each other, they're corresponding. They go with each other, right? So what's another pair? What does it look like another pair of corresponding angles is?
7 and 3.
7 and 3 are corresponding. Fantastic. Nick, how about you? Do you see some more corresponding angles? Ooh, Emily, welcome. I didn't see that you joined in. Both of you guys answering at almost the exact same time. 4 and 8 are corresponding. Fantastic. Oh, I should have done a different color. Let me change it. 4 and 8 are corresponding. It's kind of the same color. I shouldn't have done that one, but whatever. And then last pair, 6 and 2. Emily, nice work. Okay, so that's corresponding angles. And we didn't talk about that so much last time, but I should have. So, but with that, so we have these corresponding angles. That's one angle relationship. The next one is a linear pair. And I did the same exact picture, just moved it around because I didn't want to have a whole bunch of drawing on one thing, which is what I did last lesson. A linear pair is a pair of angles that are adjacent, in other words, right next to each other, and supplemental. What does supplemental angles mean? They add up to what?
180 degrees.
Fantastic. 180 degrees. Perfect. So then you're looking for lines, angles that make a line, basically, is what it is. So I'm going to give one example. So linear pairs. Linear pairs. We can say angle 1 and angle 2. And then here's a question. Angle 1, and what's another one that's a linear pair to angle 1?
4.
Yes. Angle 4. And with that, yeah, we know that they add up to 180. If we wanted to write it, I think it's going to change this a little bit of a different color. We could say that the measure of angle 1 plus the measure of angle 2, let me zoom in on that, plus the measure of angle 2 is equal to 180 degrees. We could also say that the measure of angle 1 plus the measure of angle 4 equal 180 degrees. Okay, let's list some more. So we had 1 and 2, 1 and 4. Then we have angle 2 also goes with what? What's a linear pair to angle 2?
1 or 3.
1, oh yeah, 1 or 3. So we already had the 1, so I'm just going to say angle 3, right? Because technically that's the same thing as that, right? could say that. And then have we got all of them? Let's see, we need angle 4. Angle 4 is congruent to what other angle? We already had 1. Not congruent. The linear pair to what other one? Angle 4 and angle. So Jackson's spoken a bunch. So Emily and Nick, can you guys see what angle 4 is a linear pair to what other angle? We already talked about 1. Yes, we did 1. 1 and 3. Fantastic. 1 and 3. So then angle. I forgot the angle symbol. So basically, they're like this. Angles that go like together like this, and you could keep on doing different colors. That's kind of my thing. I like to do colors. So technically all these different angle pairs, like all of these are angle pairs. What one am I missing now? That one right there. Oops. Different color like that. Okay, so we mentioned all 4 of those, and we'd have the same 4, just different numbers on the ones below. So we have angle, that was undo. We would have angle 5 and angle what? Actually, you know what? Yeah, 6. I'm just going to keep on going through it. Angle 5 and angle 6. Angle 5 and angle 8. Angle 7 and angle 6 and angle 7 and angle 8. Okay. And from that, we can get a lot of other things. Because if we were to go like this, and I knew that the angle 1 was some degree right here when I did this adding thing. Let's say that angle 1 was 100 degrees. Then what would angle 2, like if I knew that this right here was 100 degrees, in other words, this one was 100 degrees, what do we know that angle 2 and angle 4 both have to be? Emily,
80.
you are on top of it. Yep, 80. So this would have to be 80, which what that shows us, both of them would have to be 80. So if we did that, then if this was 100 degrees, then this would have to be 100 degrees, and this would have to be 80 degrees, and this would have to be 80 degrees. And it also happens because they are corresponding, that angle 1 and angle 5, since they're corresponding, this is also 100 degrees, and this is also 100 degrees, and this is also 80 degrees, and this is also 80 degrees. Do you guys remember, and we talked about this briefly last time, measuring an angle with a protractor, and then in school, it was like a pretend sword type of, I could slice pizza, Anyway, so that's the angles that if you were to measure those, it would be approximately those things. Okay, and that leads us to this point, is all obtuse means greater than 90 degrees. And if you have this situation, then all obtuse angles are congruent. So that's what I put right here. Let me, in fact, slice it. Oops, undo. Slice it and put it up here. All obtuse angles are congruent. And similarly, all acute angles are congruent. So congruent means they have the same measure, the same length. Then we come to alternate interior angles and alternate exterior angles. Alternate interior angles are corresponding angles that are on the inside of the parallel lines, the interior, and these are on the exterior of the parallel lines. So, and they're on alternate means opposite sides of the transversal, and then interior inside the parallel lines. And so again, alternate. So angle 4, let me draw this with the blue that I had. So angle 4 is congruent to angle 6 because they are alternate interior angles. So the 4 is on the left side of the transversal, the 6 is on the right side. The 4 is below, like inside, and they're both inside the parallel lines. And it's just kind of like opposite sides of the line on the opposite corner. So 4 and 6 go together. They're alternate interior angles, or 3 and 5 are alternate interior angles. Oh, I should have just left the same color as the exterior ones I said was green. Those are the same. Or if we had alternate exterior, it's the same idea. So 2 would be an alternate exterior angle to which angle? Nice
8.
job, Emily. Yeah. And then 1 would be alternate exterior to angle 7. Okay. Then the last part of these is a vertical angle, which doesn't necessarily have to do with these, but it's really helpful to remember. This is how I remember vertical, and we talked about this last time. And let me just recap it. If we have vertical angles, they make this V and A thing. So 1 is the same as 3, 5 is the same as 7 because they are vertical angles, or 8 is the same as 6, and 4 is the same as 2 because of vertical angles. Okay, so that's the stuff from GCO 9 that is specifically with just lines and like parallel lines, but there are also some parts that are have to do with triangles. So these are the parts that have to do with triangles. We did not go over this in the last lesson. So an isosceles triangle, one of my favorite things that somebody described about isosceles triangles is that it hangs in your closet. So that's why I drew a hanger there. Remember that isosceles triangles have triangles that have two sides that are congruent. And then this technically, like this statement right here, is technically part of GCO 10, but I'm just mentioning it here. So if you had the angles opposite of those sides, so like if I knew that this side was congruent, let me zoom in, this side was congruent to this side, then the angles that are opposite those are also congruent.
Excuse me?
Yeah.
Have we done like the drawing triangles with circles, like with a compass and stuff?
So that's part of the constructions. That is lesson 3 in the first unit. And because of the construction of everything with a compass that we had in the system, it was very awkward. So we skipped over it because it's just not convenient with the things that they have. So we did have it available, but not everybody learned it. If that makes sense. Okay, next part. A perpendicular line in an isosceles triangle means that it's a perpendicular bisector. So this is the next part about lines, is a perpendicular bisector. So perpendicular, let's go back up to my little thing I had up here. Right means 90 degrees. And another way of saying right is perpendicular. So I'm going to turn this and put perpendicular. So perpendicular is 90 degrees. So a perpendicular bisector. So I'm going to put 90 degrees right here. Bisector means split in half. So if I had an isosceles triangle and we knew that CD was the perpendicular bisector, and if I knew that CA was equal to CB and AD was 8 centimeters, then how long is DB? So bisector means split in half. So let me just say this another way. If we knew, in other words, it's saying that CD is a perpendicular, that's the symbol for perpendicular, is an upside down T, perpendicular bisector of AB. And we knew that AD was equal to 8 centimeters. What does DB equal? You see my picture here? Yeah, 8 centimeters. Does that make sense? Because we know that this is split in half. So that's 8 centimeters. How long would AB be? AB then? ABB, that sounds really funny. How long is AB? Nice, it would be 16 centimeters, good. All right, so that's one example from that one. And then this is another one. If we knew that HF was perpendicular to EG, so HFEG, so we can put the perpendicular symbol there. And GI was 10 inches, and it was 10 inches. How long is EI?
10 inches.
Yeah, also 10 inches. That's like literally what you have to do for that. So that's the end of G code 9. The next part is G code 10. Geometry, and then CO stands for congruence, right? So geometry congruence, and this is the 10th thing that you had to know. So we're proving theorems about triangles. And you've learned some things about triangles. We talked about side, 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 angle, side, angle, those. But these are specific other things with triangles. So one of them you probably already know. It's that the interior angles of a triangle add to 180. It's also called the triangle angle sum theorem. Another one we already talked about was the isosceles triangles base angle. So when I had this picture up, when I talked about this, the opposite sides, these angles are called, I should change the color here. These are called base angles. So this angle and that angle, those are the base angles, are congruent. Then this one's a funky name, description, but there's a name to this. If we had a segment joining the midpoints of two sides of a triangle, so let me just draw this. So here we have a triangle. Midpoint means it's literally the point midway between of two sides of a triangle, and then connect that. So that's the segment joining two midpoints of a triangle. They are parallel. So this one's parallel to that one. And that whatever this length is, it's half of that length. And the next thing that you need to know is the median. A median, it connects the midpoint of a side connects the midpoint of a side of a triangle to the angle opposite. So here's another triangle. And if this was the midpoint of that side, then the median connects it like that. So yeah. And then it has some things that we're going to use, like there's some other facts about that we'll use in a little bit. So first example, did you guys read this example yet? So if we had this triangle, JKL, and we knew that the angle JLK, which means this one, let me change to this color. So if this was 40, that means that this part right here is 40 degrees. What is the measure of angle JKL? So we want to know what is the measure right here. So this is when you have to look at what this little symbol in the corner means and remember what they add to. 50 is perfect. Yep. Because you can do 180. You can subtract the 90 because we know it's a right triangle. So it'd be 90 degrees. I should put degrees here. And then we had that one was 40. So we have 90 subtract 40 gives us indeed 50. All right. If this was an isosceles, well, we can tell it's isosceles because both these two sides are 4. So based on that base angle theorem, what could the measures of angle M and angle N possibly be? I just give some random numbers, but what do we know those numbers have to be? Base angles have to be the same. So we could say that the measure of angle M could be equal to 45, sure. And so then what would the measure of angle N have to be?
45.
Yeah. Okay, so it could be that one, or we could say the measure of angle M is equal to 32. So the measure of angle N has to be 32, right? Okay. A triangle has two sides that are 5 units long. What could the measures of the angles of the triangle be? So this is asking all of the angles of a triangle. So you have to remember two things with this one. You have to remember that they add to 180, and also that because two sides are 5 units long, it's isosceles. Wow, I'm going to try again. Isosceles. Isosceles means that the base angles are congruent. So like if I said that one angle, and this is the last year they had a question like this on the discussions, and it was really weird. If I knew that one angle was 100 degrees, but I don't know which angle, what would the other two angles have to be? If I knew that one angle was 100 degrees, what do the other two angles have to be? Emily, that's fantastic. How did you get that? Like, can you do kind of some math that helped you figure that out? You show. Yeah. So she said, okay, they have to be two angles that are the same. So she's like, okay, if we did 40 plus 40, then when we add that 100 in, then it would equal 80. Is it possible to have two angles that are 100 degrees in a triangle? Is it possible to have two angles that are 100 degrees in a triangle? Emily, why not? Yeah, it would be 200, which is already more than 180, right? Okay, so if, what if I knew that one of the angles was 60 degrees? What would the other two, what could the other two angles be?
20 or no?
So there's two situations with this, as I see it anyway, because we know it has to be isosceles, right? So we know that it could be, this could be like the base angles, right? And so let's just draw that picture. If this was 60 and this was 60, then this up here would have to be, to make it 180, what would that one have to be? Sixty is 120, and 120 plus what equals 180? It would also have to be 60, right? But what if we had, oh, I guess actually that's the only thing with 60 degrees, right? We could have one that was 45. No, that's going to make it too complicated. Let's say it was 70 degrees. So we'd have to have, this would have to be 60, 60, 60. If we had 70 degrees, we could have two that are 70. And then the other one would have to be what? 40, good job. Or if we could have 70 be the top angle, and so the other two would have to be, I mean, the non-base angle. So that means that you would have 110 left. And then what is 110 divided by 2? Okay, so on that question, just make sure that whatever you answer adds up to 180, and that two of the angles are the same. All right. If PQ is a median, and again, remember that means that we have that Q was a midpoint of SR, and then it connected to P. And this is part of what I was talking about. What do we know about the area? So let me draw the area of PQR. So here's we have the area of PQR. how do we know? What do you think, just kind of your gut feeling, what do you think it compares to as far as the area of PQS?
You mean like percentage wise, like
Well,
how
like,
much of the triangle is being taken up?
kind of. Yeah, that's kind of an idea. Because PQS, you'll notice, is like basically the other half of that triangle.
I feel like QPR has like more though.
It looks like QPR, like triangle PQR has more area, you think,
Like a
than
little bit.
PQS. Yeah, and the fact is, so here's the fact. So fact is that the area of triangle PQR is congruent to the area of triangle PQS. Weird, right? And let me just share the idea behind it, the proof behind it, like a quick proof. What's the formula? Do you remember the formula for the area of a triangle? Do you remember the formula for the area of a triangle? Anyone?
I was not taught this in my other school.
Oh, okay. It is. There's a couple different ways of writing it. This is my favorite way of writing it. It's the base of the triangle times the height of the triangle divided by 2. Or you can write it 1/2 times the base times the height. They mean the same thing. So the base and the height, the main thing that we need to know with this is that the base has to be perpendicular to the height. So we have these two triangles. We could call this the base. But because of the definition of the PQ being a median, that means that the Q split SR in half. So that means both of these have the exact same base, right? Because that's what it means by it being a median. And then the height, though it's not technically, it's not part of this triangle, the height would be perpendicular to those. So right here, and I'm just going to go like this so we can see it lines up. So perpendicular, that's the height. So they both have the same base because that's the definition of a median. They have the same base, and both triangles have the same height. Therefore, the triangles would have the same area. Mind blown? A little bit? Just a small little. Nice job in remembering that and writing that formula. I think it's hard to type those formulas, Emily. Okay, so then this is the last part of the thing that we talked about. Is it's the medians. Okay, we talked about the interior angles of a triangle add to 180. We talked about the base angles are congruent. We talked about the median. So now we're going to talk about this. The segment joining the midpoints of two sides of a triangle are parallel to the other side, and this is supposed to be and, not 8, and half the length. So here's the question with it. If W is a midpoint of TU and X is a midpoint of VU and TV is 10 meters, how long is WX? Even though, honestly, this does not look like it, but it's true. Yeah, it's 5 meters. So let me just do, this is the whole, and this one was the half. So that's why it was half of 10, which is indeed 5. Okay, this last one, I want you guys to come up with numbers, whatever numbers you want. How long should we say that AB is?
5 centimeters.
5 centimeters. Okay, CB.
5 centimeters.
Let's do some weird decimals. So let me do like 4.9 centimeters. And then AC. Should we say 4.8? So if we know that those all like AB was, these were the lengths that they gave us, here's my question. Here's the question. What is the perimeter? of triangle XYZ.
Okay, so since it's basically 4 triangles that are all the same size, correct?
Not yeah, maybe.
So
Yeah,
like ABC is the same as ABZ.
mm-hmm. This
So
is
then
definitely one way that you can do it. Yep.
so then A to Z is 5 centimeters.
Mm-hmm. Actually, and then Emily's doing it. You're right. So like A to Z. Let's see. This no. So this is 5 centimeters. So Emily's got this going on in the chat. If this is 5 centimeters, then this whole thing right here is 10. You see that? And you are what
Yeah.
you're saying is also true. I don't want you to think that I'm like saying it's not true. This is using like the theorem that we just talked about. This is using the theorem, but what you're saying is also true. So let me
And it's probably easier what you're doing.
I think it is easier, but what you were saying is not false. So I don't want you to think like I'm dissing you. Because basically what you're saying is that this side is the same length as this side, which it is, right? Because it's going to make the triangle that's the same thing. But then it's easier just to say that this whole thing actually, so that would be 9.6, right? And let me go back to the other color. This is 10 centimeters. And then the other one. And then if this is 4.9, and what you were saying again, Jackson, is that so this little triangle right here, like the ABZ, yeah, that's the same size of triangle as the ABC, but then you're dealing with 4 triangles, and that's more complicated, and you don't need to do that so much. So this is 4.9, then that means this whole side right here is 9.8 centimeters. And then just like Emily's doing, you do 10 plus 9.8 plus 9.6, and you get 29.4 centimeters. Got it? Okay,
Yep.
so that is the end of both evaluations. If you've already taken the evaluations or the assessments for that, then great. If you haven't, you're welcome to take it right now. And that is the end of what I have for you. I'm going to stop recording. Do you guys have any questions before I stop recording?
Nope, I think I'm good.
All right, I'm going to stop recording.